Hi everyone, I am Chan Mao, a community evangelist at Alexio, and I am here with Sean, a software engineer, to introduce a new series about getting started with Alexio on Kubernetes.
Hi everyone, I'm Sean, a software engineer at Alluxio. As more organizations turn to Kubernetes for its containerization and cloud-native ecosystem, running large-scale analytics and AI and machine learning workloads on Kubernetes has become increasingly popular. There's a growing need to use Kubernetes to automate the deployment, scaling, and management of query and training engines such as Presto, Trino, Spark, TensorFlow, and PyTorch, along with Alluxio to accelerate the queries and trainings. In this series, I will be demonstrating step-by-step how to deploy and run Alluxio on Kubernetes to accelerate analytics and training workloads. In this video, I will first be introducing the architecture of Alluxio on Kubernetes.
So before we go for what's really actually going on while deploying Alluxio on Kubernetes, let's first look at why we even do this. So first of all, the resource provision would be much easier if we deploy on Kubernetes. This including network, system setup, etc. For example, if you are using on-prem machines, you have to configure all the private networks in your machines, and you need to set up all the softwares, not only including Alluxio, but also includes all the, for example, operating system and stuff. But on Kubernetes, since everything is in Docker, the Docker image already predefined everything for you. So there's no need to manually run all those commands and customize your cluster. Second, we can achieve multi-tenancy by deploying on Kubernetes. This means you can give different Alluxio clusters to different teams in your organization. This is really hard to achieve if we deploy Alluxio on either on-prem or not on Kubernetes, basically. The third point is it's easier to deploy on Kubernetes. We have Helm charts and operator that already sandbox all configurations of Alluxio so that you don't have to manually look at each configuration inside Alluxio and then copy all of them on all of your machines. And last but not least, the security perspective. Since we are deploying Alluxio in Kubernetes, that means everything is in containers. And containers provide isolation, including network, including resources, so that extra security is included in this scenario. Okay, now let's jump on to the architecture of deploying Alluxio on Kubernetes. So first, the Alluxio master. We deploy Alluxio master as default set in Kubernetes. And normally we would deploy multiple copies of master so that we can have a forum and we can achieve high availability. So that means if one master for any reason is down, the other two can still function as normal and still providing service to your application. So in each Alluxio master pod, we have two containers. One is the master container and the other is the job master container. And they can be found by other services, including applications, clients, and other Alluxio components through service. Service is a term, it's a Kubernetes term that can fix the host name of Alluxio master. So for any reason, the master pod is down and restarted, they can still be found by using the same host name. And we give each pod a corresponding service. And then for Alluxio Worker, which stores all your cache data, we deploy it as daemon set. Daemon set means we deploy one copy of Worker on each host machine of your Kubernetes cluster. Of course, you can configure this by adding some, say, node selector and other affinity stuff so that you don't have to put every worker on, put a worker on every single machine in your cluster. So for each worker pod, we have the worker container and job worker container. The worker container will be the one that stores all your data, cache data in Alluxio. So these two components, Alluxio master and Alluxio worker, form our basic Alluxio cluster. So Alluxio master stateful set will consist a few master pods for high availability. And a worker daemon set will have multiple worker pods for storing your cache data. And then Alluxio clients, which can be Java, Alluxio Java clients or other types of clients. They will find Alluxio master through your configuration file so that it can communicate. And then the clients will then ask data from worker. So the architecture not complicated. It looks pretty much the same as on bare metal machines, but we put in the Kubernetes environment so that they can be easier to be managed on Kubernetes.
Thank you for tuning in to our new series. In the next video, Sean will be demonstrating how to deploy Alexio on Kubernetes. Our docs page about running Alexio on Kubernetes is linked in the description below if you want to read ahead. If you have any questions, make sure to join our Alexio Slack community, and our experts will be happy to answer your questions. Thanks for watching and stay tuned for the next video.